Let us discuss the next problem. So problem number 1.72. So again, this is a easy problem basically. So let us first make the diagram. I think you have tried this problem. Some of you may have got the answer, I think. If you are not getting the answer of these problems, so there is basically some problem. So let us say you have this system and there is a pulley again. So this is attached to a pulley and this as a thread, and this thread is basically fixed here. And on this side you have a thread, I think you are able to see. This side you have a thread that is attached to a mass. Let us say this side you have a mass. Now this pulley also contains a mass. So this side there is a mass. Let us say this mass is m. Now question says mass of this is m, but the mass of this is that is attached is eta times m. This angle is given to you alpha. System are frictionless, so there is no friction. We have to find what is the acceleration of block 2. So we have to find acceleration of block 2. Acceleration of block 2. This is the e time. So let us call this as a block 1. This is a block 2. So acceleration of block 2. We have to find out what is the acceleration of block 2. So this is a pretty easy problem basically. Only one thing we need. What is the relationship between acceleration of this block and acceleration of this block? So let us say acceleration of this block is a, and I am going to ask a question. What is the acceleration of this block? That is the block number 2. So what is the acceleration of block 2 in terms of a? So you give me the answer, block 2 acceleration in terms of a. I have given you acceleration of block 1 is a. What is the acceleration of block 2? So let me see how many of you are able to do this one. Okay, so let us try to think. Sorry. This block is going up. So let us say this block goes up by a distance x. If this goes up by x, what will happen? This whole system will go up by x. Now this point will come x downward. If this comes x downward, this means this string x string becomes slacked. This side also, this x string becomes slacks. So basically there are two x string, this string and this string. So there is this distance is x. If this string goes this side by x. Now you see in this case the total string, that is x this side and x this side. So 2x a string basically becomes slack. Basically 2x a string becomes open. So you see if this becomes open by x, this goes up by x, this string becomes open by 2x. This means this block goes down by 2x. So this means if I differentiate 2 times, acceleration of this block is a, acceleration of this block is 2a. Are you getting or not? One important point in this problem you have. So acceleration of this block is 2a. This is with respect to ground. Are you getting? So this is the acceleration 2a. This is with respect to ground. So somebody sitting on the ground will see this block is coming by 2a acceleration, because if this goes by a, this goes by a, and this goes also by a, so a plus a 2a, so this total will come out by 2a. Now things are very simple. You have to simply write down the equation and solve the equation. So you see what are the forces that is acting. So let us say this is T, downward direction you will have eta mz. This will come by acceleration 2a. Now if this is a tension T, so let us make for free body diagram for pulley. So this pulley, I am making a free body diagram for this pulley. You see on this pulley there will be a tension T this side, there will be a tension T this side. So on this string basically pulleys are massless, so this is tension T, this tension is T. So this tension has to be 2T, because total force up is equals to total force down, because this pulley is massless. So now you can say there is a 2T up. So in this case there will be 2T force that is acting this side. Are you getting? So on this rope there is a 2T. Now this side you will have mg cos alpha, mg sin alpha, because inclined towards the inclined force acting is mg sin alpha. Let me ask if you are getting or not. What we have said in this problem till now, we have said only two things. One thing is, if the acceleration of this block is a, then acceleration of this block will be 2a. This is the first point. And the second point we said, tension in this is T, so tension here will be T. So here you have a tension T, here also you have a tension T. So this means here we will have tension 2T. Once you have 2T, so this whole string will be a single string, so this will have a 2T tension. Now simply write to the equation. So for this block, 2T that is acting up minus mg sine alpha that is acting down, and this is going up, so mass into acceleration. So this is my equation number 1. Now for this mass I can write again equation. So this is coming down, so force is eta mg minus t. This is equals to eta times m, and acceleration is 2a. So this is my equation number 2. So what can I do? I can multiply this equation by 2 and then I add. So this tension 2t goes out, so we will have 2 eta, I think you are able to see, mg minus mg sine alpha. So this will be 2 into 2, 4 eta m. Let us say ma I will take common, so 4 eta plus 1 into m into a. m throughout cancels, so we will have acceleration is equals to 2 eta and minus sine alpha divided by 4 eta plus 1, and I can take z common. So this is my resultant acceleration we will have. So you copy this one. So this is the A. So what is the acceleration of block 2? So block 2 is basically coming with acceleration 2a. So acceleration of block 2 I can write. So block 2. So acceleration for block 2 is basically 2 times a. So I have to multiply by 2. So 2 into 2 eta minus sine alpha divided by 4 eta plus 1 into z. So this is the resultant acceleration of block 2. So I copy this one first and then we will discuss the next problem. This is a pretty easy problem, you can see. Are you getting or not? So what we have done, this is a fairly easy problem. And one important point, you have two important points. Acceleration of relationship between acceleration and relationship between tension. If one goes, so this block that is in incline goes by distance x, another will go down by 2x, and if the tension in one string is T, tension in other string will be 2T. That is the one important point we have here. If somebody is missing something from top, so let us copy from top. If you miss something, okay, let us discuss the next problem.